Hi there, in this video we're going to start our discussion of the derivative of polynomials and exponential functions. So we're moving away from using the definition of the derivative, although we will use it to come up with the shortcuts. So let's look at this problem. Use the definition of the derivative, which is this limit we have been using to find the derivative of y equals mx plus b, just a line, and for that cubic. Now remember, the derivative gives us the slope of the line tangent to the function. This is already a line, so we should expect that the derivative, because this is already a line and the derivative gives us the slope of the line, so we should get m. But just to go through the definition, let's see. So for f of x equal to mx plus b, f prime of x will be, using our definition, if you're asked to use the definition of the derivative, that's what you need to use. So limit as h goes to 0 of f of x plus h minus f of x all over h. So let me not write the whole thing and put it already in the function. So let's say m times x, but in place of x, we're going to put in x plus h plus b. So this is my f of x plus h minus f of x. F of x is mx plus b. The whole thing divided by h. And let's distribute. So I have the limit as h goes to 0 of mx plus mh plus b minus, distribute this negative in, so minus mx and then minus b. The whole thing divided by h. So let's combine like terms. And so notice that mx minus mx, those cancel, and plus b minus b, those cancel as well. So what are we left with? We're left with just mh in the numerator. So this is the limit as h goes to 0 of mh divided by h. And h divided by h, those reduce to 1. So I'm just left with the limit as h goes to 0 of m. And properties of limits, there's no h in here, so this is just going to be m, which is what we expected, right? If you graph the line y equals mx plus b and put a tangent line on there, the tangent line is going to just lay right on top of that line, so we should expect that the slope of the tangent line to just be the slope of the line. So that makes sense that we get m, but this just shows you how to do it with the definition. Now for part b, f of x is x cubed. Find the derivative of that using the definition. So for our part b, so for f of x equals x to the third, our derivative using the definition will be the limit as h goes to 0 of f of x plus h. So this will be x plus h cubed minus f of x. So f of x is the original, so x to the third all over h. And in the prior videos, we have expanded x plus h quantity cube using Pascal's triangle, which tells us this is 1, 3, 3, 1. So this gives us the coefficients of our terms for the cubic expansion. So I'm going to have the limit as h goes to 0 of 1. So x to the third, 1x to the third plus 3, my next one, 3, x squared h. Remember, when we do the Pascal's triangle expansion, the first term starts with the highest exponent and it decreases, and then the last one, the exponent increases. So I'm at 3x squared h to the first plus my next coefficient 3. The x decreases, so from x squared to just x, h increases, so from h to the first to h squared plus 1 h to the third minus x cubed all over h. Combine like terms. Here the x cubes cancel out, and so we're left with the limit as h goes to 0 of, notice that everything that's in here has an h, and that's because then we want to be able to factor that h out. So 3x squared plus 3xh plus h squared. all over h. Our goal with the difference quotient is to be able to cancel out this h. H divided by h is 1. I can only do that because I am multiplying, right? Once I have factored it out, it's multiplication, so I can divide out with the denominator. I can't do it from here, right? I can't say h cubed divided by h. I can't just do one of them because this is a whole quantity up there. So what are we left with? Limit as h goes to 0 of 3x squared plus 3xh plus h squared. And as our h approaches 0, we can take the limit. So plug it in. And those terms are going to be 0 and 0. So I'm just left with 3x squared. And so that is our derivative. So what we're getting at is, so far I have, so if f of x is equal to just x, what's the derivative? And we can do it real quick, right? The limit as h goes to 0 of x, f of x plus h, so it's going to be x plus h minus f of x minus x all over h. So my x's cancel, I'll be left with h over h, which is 1. So this will just be 1. So f prime of x is 1. If f of x is x squared, what's the derivative? And we'll do it here on the side as well. So it'll be the limit as h goes to 0 of x plus h squared, right? F of x plus h minus f of x all over h. And if you simplify this, by now you should be pretty proficient of finding x plus h squared. So that's x squared plus 2xh plus h squared minus x squared all over h. If you're not, that means you need to practice some more, you need to do some more homework. And notice that everything that's left has an h in it. So factor the h out, and you're left with 2x plus h all over h. So these are going to cancel. And as h goes to 0, that will go to 0. So I'm just left with 2x. So the derivative of x squared is 2x. Above, we did the derivative of x cubed. What did we get for the derivative of x cubed? We got 3x squared. So what do you notice? So can you guess then what's the derivative of x to the fourth? Without doing the math, without doing the definition of the derivative, what is the derivative of x to the fourth? Yeah, it's going to be 4x to the third. So notice that what looks like what we're doing is we're taking the exponent and bringing it to the front and then decreasing the power by 1. So here, take the exponent, bring it to the front, and then this came from doing 4 minus 1. So that brings us to the power rule. So the general power rule for derivatives, which says that if I have f of x equal to x to the n, based on what we noticed above, what is the derivative? I'm going to bring the power down, so the n becomes the coefficient, so it'll be n x to the, right? So the power becomes the new coefficient, and the exponent will decrease it by 1. So this will be n minus 1. And so this gives us a shortcut of finding the derivative. Now, what if you had a constant in the front? So say f of x is equal to 5 times x squared. What will this be? We can try it with the definition. The limit as h goes to 0, you're going to have 5 and then x plus h squared minus f of x minus 5x squared. So it's going to be essentially the same work that we do above when we did it here. It's just that I'm going to have that 5 out front. So what I can do from here is use my rules of limits, properties of limits, and be able to take that 5 outside of the limit. So this is really the limit, 5 times the limit as h goes to 0 of x plus h squared minus x squared over h. And I already know that this is 2x. So the whole thing is 5 times 2x, which is 10x. So when f of x is 5x squared, f prime is 5 times essentially the derivative of x squared. So 5 times 2x, which is 10x. So the constant multiple rule is that if I have f of x equals c, some constant, times x to the n, this becomes c times, I still do my general power rule on x to the n, so it'll be times n, x to the n minus 1. And so you just have a new coefficient, c times n, whatever that constant was. So a quick example, say g of x is 17x cubed. What is the derivative of that? Well, I will say my c stays, so 17 times, and I'm going to do the derivative of x to the third, so it's 3x squared. Which then gives us, what's that, 51x squared? And so that is our constant multiple rule. Now what about our other rules of derivatives? Now that we have this shortcut of the general power rule, we can do a lot more. So the other rules of derivatives are the sum and the difference. The sum and difference rules say that if both f and g, that should be an f, are differentiable, then when you take the derivative, so d dx, the derivative with respect to x of the sum of f and g is the same thing as taking the sum of the respective derivatives, the derivative of f plus the derivative of g, and the same for the difference. So let's start with these functions, and then we'll put it together with addition and subtraction. So find the following derivatives. So these look like I can just use the general power rule. So for f of x equal to 3 to the 5th, f prime of x is 3 times 5x to the 4th, right? The constant just kind of tags along, which will be then 15x to the 4th. And then what about x to the 1/3? So f prime of x here, 1/3, that's still a number. So then this is going to be, bring the exponent down, so it'll be 1/3 x to the exponent minus 1. So 1/3 minus 1. So what does that become? So it's x to the, get a common denominator, 3. So 1 minus 3/3, so it will be negative 2/3. But we don't want to leave things with a negative exponent, so make sure that you write your answers with positive exponents. So this will be 1 over the 3 that's in the denominator there, and then this x to the exponent comes to the denominator, because negative exponent means it really belongs at the bottom. So this will be x to the positive 2/3. Now if you want to get fancy, you can rewrite it some more and say this is the what? Which root? How do you rewrite a 2/3? The bottom is the radical, the index of the radical, and then the numerator is the exponent of the variable. So this will be the third root of x squared. So you can leave it like that. And what about part C? F of x equals 2 over x to the third. So I want to be able to use the general power rule that if I have f of x equals x to the n, the derivative is n x to the n minus 1. But here I don't have x to the n, I have 2 over x to the n. So how can I write it as x in the numerator to the n? We can bring it upstairs, right? So right now it's in the denominator, we can bring it to the numerator as a negative exponent. So it's 2x to the minus 3, that's f of x. And now I can use the general power rule. So bring the exponent down. So it'll be 2 times negative 3 x to the negative 3 minus 1. And so this becomes, what's that, negative 6 x to the negative 4. Again, we don't want negative exponents, so this will be minus 6 over x to the positive 4. Now here, be careful. Oftentimes I see in answers, so a word of caution here, right? When you have minus 6x to the minus 4, that is not 1 over 6x to the fourth, right? The coefficient doesn't go to the denominator unless it was as an exponent. I mean, that's in parentheses. So if you had minus 6x and then that to the negative 4, then this will be 1 over minus 6x to the fourth. And that's still not right. So it should be parentheses there. So that's when the whole thing will come downstairs. That's when the coefficient will come downstairs too, if it's in the parentheses and the whole thing is to the negative. Here, the negative 4 only belongs to the x, so only the x goes to the bottom. And how about, let me add an example that is not in the notes. What about f of x? So find f prime of x for f of x equals c. Just a constant. What's the derivative of just a constant? And so what is the slope, right? The derivative, it gives you the slope of the line tangent to the graph at a point. So what is the slope of this? This is really the line y equals c. This is a horizontal line. What kind of slope do horizontal lines have? The slope is 0. So here f prime of x should be 0. If you're not convinced, you can try the derivative definition. So the limit as h goes to 0 of f of x plus h. So everywhere you see an x, you plug in x plus h, but there's no x here, so it's just f of x plus h will be c. There's no x to plug in the x plus h, minus f of x, which is also c, all over h. So you just get the limit as h goes to 0 of 0 over h, but that's just 0. So the derivative of a constant is 0 if the constant is not attached to a function of x, right? Like here, 3x to the fifth, you get 15x to the fourth. So that constant, that 3, is not a constant by itself. It's not a constant function. It is the coefficient of a polynomial function. So that's kind of like the big difference. So let's try another example. In this next example, we're putting everything together. So the general power rule plus the sum and difference rules, because you can think of 3x to the fifth as a function, 4x squared another function, so we're subtracting them. And then the cube root of x is another function, so now we're adding them, and so on. So what is the derivative of this? Well, I know that I'm going to use the general power rule on most of them, but some look a little funky, so I want to be able to rewrite the ones that look a little funky. So these two look a little funky. I had to redo part of it. My pen went a little crazy there. So those don't look like the general power rule. My general power rule is f of x equals x to the n. And with the constant is cx to the n. So I want it to look like that. And right now they look a little funky. I have a radical and I have a denominator. So let's first thing is rewrite before you take the derivative if it needs it. Right, in this case, these don't look like polynomials, so I want to make them look like a general power rule. So I'm going to have f of x is 3x to the fifth minus 4x squared. Those don't need to be rewritten. But then this one needs to be rewritten. So it's plus x to the what power? So this is the cube root of x, so that will be x to the 1/3. Radicals can be rewritten as rational exponents. Minus 5 times x to the x is on the bottom, right? So that comes upstairs as x to the minus 3. X is to the minus 3, not the 5, plus 17. And so now I can take the derivative. I can use the general power rule. So f prime of x will be, bring the 5 down, so it will be 15x to the fourth, decrease the power by 1, minus, what about the derivative of 4x squared? Bring the 2 down, 2 times 4 is 8, x to the 2 minus 1, which is 1, plus, bring the exponent down, so 1/3 x to the 1/3 minus 1, minus 5 times, bring the minus 3 down, x to the minus 3 minus 1. So some of these are ones that we did already, plus the derivative of 17. 17 is a constant function all by itself, right? So then the derivative of that will be 0. And then simplify. I will always want you to simplify your derivatives as much as possible. So go as far as you can. 15x to the 4th minus 8x plus 1/3 x to the negative 2/3 plus 15x to the minus 4. And no negative exponents, so let's rewrite it. 15x to the 4th minus 8x plus 1/3x to the 2/3. If you want to write it as a radical, back to a radical, you can. Plus, now how do you rewrite this? Who does the negative belong to? Does it belong to the whole thing, 15x, or just the x? Just the x, right? So the 15 will stay at the top over x to the 4th. And so this will be our derivative. So now I can find, remember, the derivative as a function. That means that it's giving me a formula for finding slope at any point. So now I could find the slope of this, of the tangent lines at any point on the graph. Of course, keeping in mind the domain. Notice that I have a denominator there, so x can't be 0. So even if I try to plug in 0 here, I'm going to have undefined derivative, but that's okay because 0 is not in the domain of the function anyway. Okay, and let me do one more example. This example should actually go pretty fast because we did it in the prior video series for the derivative as a function, and we did this derivative using the definition, which took us a minute, right? It was kind of long to do this derivative using the definition. Now with the shortcut, with the general power rule, we can find the derivative by using the general power rule. So this will be 4x minus 3x squared. And that's it. I have the derivative. The derivative is a formula that helps me find the slope of the tangent line at any point. And for part A, we want to find all values where the function has horizontal tangent lines. So that means for part A, we want f prime of x to be 0. So that means there's our f prime of x. 4x minus 3x squared equals 0. Factor out the x. And so now we can redo the work that we did last time, right? So then that means this is x equals 0 or x equals 4/3. So that's where this function has horizontal tangent lines. So this is the same as when we did in the prior video series for the derivative as a function. Part B is a little different. It says find all values of x where the function has tangent lines perpendicular to this line. Last time in the prior video series, it was so that the tangent lines were parallel to a line. So this is a little different. So what do you know about perpendicular lines? They have slopes that are opposite reciprocals of each other, right? So in this case, we want to find the slope. So find the slope, and then we want f prime of x to be the opposite reciprocal of that slope, because that's what it means for lines to be perpendicular. So let's work on that. So I have my line here, so let's find m. And so to find m, you want to put it in y equals mx plus b, so we can pinpoint what m is. So let's go here. So minus 2y then equals negative x plus 3. Divide both sides by minus 2, right? So then y will be 1/2 x and then minus 3/2. We're interested in the slope. So our slope here is 1/2. Now, because we want the lines to be perpendicular, we want our derivative to be the opposite reciprocal of our slope. So that means that we want f prime of x to be opposite. So this is 1/2 positive, so we want it to be negative. And the reciprocal of 1/2 is 2. So we want f prime to be -2. So let's go back. What was f prime? Our derivative was 4x minus 3x squared. So that means we want 4x minus 3x squared to equal -2. And then set this equal to 0 and solve. So I want 0 to equal 3x squared minus 4x minus 2. And does this factor? Two numbers that multiply to -6 and add up to -4. Probably not going to factor, so we can use the quadratic formula. So x equals the opposite of b, so 4 plus or minus b squared, so -4 squared is 16 minus 4ac all over 2a. And simplify that. So 4 plus or minus, what does that give us? Divided by 6 here. So let's work on that radical. So I have 16 minus and minus become plus, 4 times 3 times 2, that's 24, right? And so I have 4 plus or minus the square root of 40 over 6. And can you reduce that some more? Sure, I can say this is 4 plus or minus 40. What's 40? So the square root of 40 is the square root of perfect squares. So 4 times 10. And then the square root of 4 is 2. So it's going to be 2 times the square root of 10 all over 6. And this is where, as we talked about in a prior video, you have to be careful how you reduce, right? Be careful not to say, oh, 4 and 6, I can reduce that. You have to be able to reduce from the entire thing. So what I'm going to do is I see that 6, 2, and 4 have a common factor of 2. So I'm going to factor the 2 from the numerator. So this will then give me 2 plus or minus just the square root of 10 over 6. Now, because I have multiplication, I can reduce the 2 and the 6. That becomes 3. So my final answer is x is 2 plus or minus the square root of 10 over 3. So what did we just find? We have find all values of x where the function has tangent lines perpendicular to that line. So our function has 2 tangent lines that are going to be perpendicular to that line. One at x equals 2 plus root 10 over 3, and the other one at x equals 2 minus the square root of 10 over 3. So at those two x values, we're going to have tangent lines to our function that are perpendicular to that line that we were given. Okay, in the next video, I'm going to talk about the derivative of an exponential function.